Okay, guys, good morning. So we're going to be going over Stoichiometry 1 today on the whiteboard here. So what you need before you get started here, you're going to need your periodic table and the Stoichiometry 1 worksheet. Hopefully you can just pull that up on another screen. What I want to do is I kind of want to work through each one of these individually, and I suggest that you stop and pause each time after each problem here. Okay, so for this first one, so what is stoichiometry actually? What is stoichiometry? Well, stoichiometry is a way of figuring out if we have a certain amount of this, so grams of this, how much of each product are we going to make? Right, so stoichiometry tells us that. It can also be in moles and tell us how many moles we can make, how many molecules we can make. And then sometimes with gases, we can use this with gases too, and tells us volume as well. Okay, so this is stoichiometry is a way to quantify how much products or reactants we make, or how much reactants we need. So products we can make, or reactants we need to make a certain amount of products. Okay, that's what stoichiometry does for us. Okay, and when I teach you how to do stoichiometry, I ask you to do it a very specific way. Okay, but before we get to that, the first thing we need to do is how to come up with these molar ratios. And simply, molar ratios are a ratio of one element or one molecule to another in a chemical reaction. Okay, and the reason that this is important is because the only way we can go from some amount of this to amount of this is through a molar ratio. Okay, so the first part here in number 1, letter A, it asks us to find the molar ratio of C4H10 to O2. So what is the molar ratio of C4H10 to O2? So it's really, really simple. We just look at the balanced chemical equation and we write the coefficients on the balanced chemical equation. So here there's a 2 in front of C4H10, and for O2 there's a 13. So the molar ratio of C4H10 to O2 is 2 C4H10 for every 3 O2. Sorry, not 3, 13 O2. Oh my goodness. Okay. The next one, letter B, is what is the molar ratio of O2 to CO2? So again, we look at the balanced chemical equation. It's 13 O2 for every 8 CO2. Okay, so take a second, pause the video for a second here, and go and try and do C, D, and E on your own. All right, I'm just going to keep going, but you should pause it and then give it a shot on your own here. Okay. Okay, letter C. So hopefully you paused it and now you're back. Letter C says O2 to H2O. O2 to H2O. So again, just the coefficients from the balanced chemical reaction. So 13 O2 for every 10 H2O. Letter D says C4H10 for every CO2. So it's 2 C4H10 for every 8 CO2. Now you'll notice that this is 2 and 8. We can reduce that to 1 over 4. So 1 C4H10 for every 4 CO2. I honestly don't care. Either answer is fine with me. Okay? I actually, personally, I prefer it this way just because that's what's from the balanced chemical equation. But ultimately, when we do the math on these things, this one's going to be what's happening in reality. So it doesn't really matter. Okay? The next one, C4H10 for every H2O. So there are 2 C4H10 and H2O is 10. So that was E. So again, this one you could reduce to 1 over 5. Okay, it's really important that we do include the elements here. So make sure you're writing this Don't write 1/5. Don't do that, right? Include the molecules here, please. Okay, include the entire molecule, all right, when you're doing the molar ratios. Okay, so we need these molar ratios to do the next step. And the next step is really, that wasn't even stoichiometry. That's just really setting up to get ready for stoichiometry. So the next part, if we have a reaction like this, we have two, so this is number 2. We have 2 KClO3 yielding 2 KCl plus 3 O2. Okay, so the question asks how many moles of O2, so I usually like to write a question mark, how many moles of this can we be produced by letting 12 moles, so we have 12 moles of this, how much of the O2 can we make? Okay, and in order to figure that out, we use molar ratio. So when we do these problems, you need to do them the way I ask you to do them. So we start with 12 moles of KClO3. So you need to write that, KClO3, 12 moles of KClO3. Next, a little bracket, and these brackets just mean times. Okay, we're going to multiply, and this here is going to be our molar ratio. Okay, so the only way to go from moles of one thing to moles of another is using this molar ratio. Now we're starting with moles of KClO3, and we want to get rid of that, so it's going to go down here, KClO3. Okay, and I don't need to write moles here, just KClO3 is fine. All right, and there's 2 KClO3 from this balanced chemical reaction. And we want to go to moles of O2. So O2 goes up here, and that's 3 O2. Okay? So I want you to do it this way every single time. Okay, every single time we're doing molar stoichiometry, you should write it this way. Okay? Now we have to multiply and divide. So if it helps, you could always put this over 1, because any number over 1, it's still the 1. Then you multiply the top numbers. 12 times 3 is 36. Divided by 2 is 18. So 18 moles of O2. And you'll see that the KClO3, it cancels out because the units cancel out. Not the numbers, but the units, they cancel out. Okay, always in stoichiometry, the units should cancel out to give you what you need in the end. Okay, and again, you always need to circle or box your answers. Okay, if you're doing this on the Google Doc, just bold it or make it bigger. Bold it and make it bigger, okay? And if you're doing these things, use the fractions method. Either fractions, or some people use tables. Tables works okay too. Fractions or tables are fine. Okay, either one works. Okay, next. Number 3. So number 3, we have the same, and on a different reaction, 2K plus Cl2 yields 2 KCl. And we want to know how many grams of KCl are produced when we have 2.5 grams of K of this, 2.5 grams of this, and excess Cl2. So this is one thing that a lot of people get confused on when they say excess. Excess means that we have an infinite amount of Cl2. Okay? We're not going to run out of Cl2. Okay? We're going to run out of K first. What's going to happen is this K is going to react with Cl2, and it's going to make KCl. And eventually, the K is going to run out, the reaction is going to stop, and we're going to have a certain number of grams of KCl. Okay? So anytime you hear excess, if you hear excess, just ignore the molecule. Okay, we're just going to ignore it. We don't need to worry about it. We don't need to think about it. We're only going to worry about the other one. Okay? So in this case, all right, so in this case we have grams of K, and we want to go to grams of KCl. We cannot simply just use molar ratio here, okay? Because this is not 2 grams of K yields 2 grams of KCl. That's not what it says here. It's 2 moles of this yields 2 moles of this. All right, so this is not grams and grams. So what we need to do is we need to convert from grams of K to moles of K, and then from moles of K to moles of KCl, then from moles of KCl to grams of KCl. Okay? So you're always going to see when we do these steps, you're always going to have converting to moles. You're always going to go to moles. One of my sayings is, when you're in a hole, convert to a mole. Okay, when you're in a hole, convert to a mole. Because moles dig out of holes, right? Or moles dig holes, but they also dig out of them, right? They can get themselves out of a hole. All right? So when you're in a hole, you're going to convert to a mole. So you're always, always, always converting to a mole in stoichiometry. The first step is almost always converting to a mole. If you're already at a mole, then you're good. Okay? Okay, so these are our steps here. Grams of K to moles of K, moles of K to moles of KCl, and then moles of KCl to grams of KCl. Okay, so it's just a bunch of conversions that we've done already. We've done these conversions already. We just got to put them all together. Okay, and instead of doing it like one step, then two steps, then three steps, we're all going to do it all like kind of in one step. Okay, so we start with 2.5 grams of K, and we're going to go to moles of K. So I like putting it over 1. So if we want to go to moles of K, and we want to get rid of grams of K goes in the bottom here. Okay, and this relationship, moles and grams, is the molar mass of K. Remember, molar mass you get from the periodic table. So K has a molar mass of 39.1. I'm just going to round that to 39. So it's 39 grams of K for every 1 mole of K. Okay, you notice how this is kind of like 1 over the molar mass. 1 over the molar mass, kind of. Okay, so that will convert our grams of K to moles of K. The next step is to go to moles of K, from moles of K to moles of KCl. So we want to get rid of moles of K. K goes in the bottom. KCl is what we want on top. And this is our molar ratio. We get it from the balanced chemical equation. It's 2 to 2. Lucky us. Then the last step. We're going to have moles of KCl, but we don't want moles. We want grams of KCl. Let me rewrite that a little bit better here. KCl. Okay. So we have moles of KCl. We want to get rid of it so it goes on the bottom. And we want grams of KCl in the end. Okay, again, use this 39 plus 35.5. What is that? It's a good question. Let me get my calculator because I don't feel like doing it in my head. Plus 35.5, and you get 74.5. Or 75, I don't really care. It doesn't really matter. Okay? All right, when we do the math here, we're going to multiply all the top numbers, then divide by all the bottom numbers. Okay, 2.5 times 2 times 74.5. Then I divide by 39, divide by 2. Oh, and this is 1. It's always 1. This is the molar mass of KCl. Okay, and I get 4.8. Okay, so make sure you include units, and then you're going to circle or box your answers here. So 4.8 grams of KCl. All right, you'll also see that the units cancel out grams of K, moles of K, moles of K, KCl, KCl, right? And you wind up with grams KCl in the end. All right? So those 2 problems, you basically should be able to do the rest of the problems given that. Okay? But I'm going to, so if you want to pause it and try the problems, go for it. And then I'm going to work through the rest of them for you guys. So if you have any trouble, I can, or you know what I'm going to do? No, I'm going to stop there. If there's any problems you guys need me to go over, please let me know and I can go over them. I'll give you the answers with the work. I'll give you worked out answers to these. And then if you want me to explain any other ones, feel free to do so. But this is the basic premise of every single problem. Okay, every single problem.